Hello everyone. So today let us study the language of chemistry. What do you understand by the language of chemistry? Like for example, if there is a newborn baby and he is trying to speak, or when he learns to speak, he start he starts with the basic terms like mom, father, all in Hindi. So these are the basic words of language which is spoken by a newborn baby when he learns to speak. Similarly, when we study chemistry, there are some basics of chemistry before learning the complete or the further chemistry. Like again, like a newborn baby, when he learns some words, that is its basic words, and when he is able to be perfect on those words, then or when he knows those words perfectly, then only he proceeds saying many other words like right now you all are speaking. Similarly is this language of chemistry, or you can say that this is the basic of chemistry. In this we'll study all the basics things like element, compound, molecule, valency, and those things. Okay, so let us first know that what is a pure substance means. What is the mother of chemistry? That is pure substance. Pure substance is that which is made up of molecules containing the same kind of atoms. Means that this pure substance is a molecule with same kind of atoms. Now, if we say the words which are in or which are significant, let us see that what is atoms. We all know that atom is the smallest unit of matter. Means that matter's smallest particle, tiniest particle is atom, which can be seen through a microscope. Then when these atoms when these atoms combine this forms the molecule. Okay, like if we say H2, this is also a molecule. In this there is one H plus H, and this forms H2. So same, atom plus atom gives the molecule. So this is what pure substance means. So by this we can say that elements and compounds both are pure substance, as these are made up of same kind of atoms. Okay. Okay. Then let us talk about element, the type or the component of pure substance, which is element. Element pure substance which cannot be broken down into any other unit. Like if we have H, we cannot break this H into more smaller, into half of this. We cannot break it into this. Then will it be called as hydrogen? No. So that is what element is. It is a simple pure substance which cannot be broken down, which cannot be broken down into more simpler units. Now here there is one term, simple pure substance. Simple pure substance means that this is made up of atom, which is the smallest unit of matter. And pure substance means those substances which are made with a same kind of atom. Like H2, this is made of H plus H atom. So this is also a pure substance. Now let us move on to compounds. Before moving on to compounds, let us know what is atomicity. This will help in the molecule portion, the compound portion. Atomicity is very simple. It just means the number of molecules I'm so sorry, number of atoms in a molecule. Like for example O2, this is also one molecule which is made up of atoms. That means how many atoms are present in this O2? Two atoms. So its atomicity will be 2. And those molecules with atomicity 2 are termed as diatomic molecule. Okay. More examples of diatomic are H2O2, N2Cl2 and many more. Now we understood what is diatom, but we directly moved on to 2. So let us seek one example of 1. Now, for example, helium. This is also a molecule. This is a molecule with one atom only. Because now there is a reason, as helium is a noble gas or inert gas, and you'll notice that only till now what is found that only inert gases have at one atomicity, because these are inert means what? Not reactive. They do not react with each other's atom, each with own atom also to form a molecule of two atoms. It remains free. Free means here single. It does not get into anything else rather than being alone. Okay, so this has atomicity 1. One atom, so atomicity will be 1, and the elements which have 1 as its atomicity is termed as monoatomic molecule. For example, all inert noble gases like helium, xenon, neon, argon, etc. Okay, now let us see those elements with atomicity 3. Like atomicity 3 means the number of atom will be 3. For example, ozone. This is made up of O plus O plus O. Okay, so that means it has 3 atoms. So atomicity is also 3, and the elements which have atomicity has 3, they are termed as triatomic molecules. Triatomic molecules. Further example is ozone. This is the only element with 3 atoms. Ozone. Now, next let us see the elements with 4 atoms in their molecule. In a molecule, okay, please do not get confused. In one molecule, a molecule means only one molecule atom. Now, suppose phosphorus. This is made up of 4 atoms of phosphorus. Okay, this termed as tetraatomic molecules. Tetra means 4. Tetra. I'm so sorry for. Atomic molecule. Example is only sulfur. Again, sorry, phosphorus. Now, next is the with more than 4. For more than 4, like sulfur, it is made up of has 8 atoms or more than 4. So this is termed as polyatomic molecule. Okay. Again, there is only sulfur as the example. Now, let us study compound. Okay. So, you all can take the screenshots or copy it. Okay, so now let us see compound. A compound now what is compound? Compound is also like molecule, but the only difference between molecule and compound is that in molecule there are same atoms of same element, but here in compound there are atoms of 2 or more different elements but in fixed proportion, like H2. H2 has 2 atoms. It has 2 atoms but of H only. So this is a molecule. But for example, H2O, what? This is H plus H plus O. This. There are total 3 atoms in which 2 atoms are of different element than the other last one. So here the atoms are of different elements and this can be 2 or more, but here there is only one element's atom. This is only the basic difference between molecule and compound. So let us see how can we define a compound. Sorry. The combination of the two or more elements atom in fixed proportion is termed as compound. Okay, now here main is that in fixed proportion, because if it will not be in fixed proportion there will be no difference between a mixture and a compound. Okay, so the main thing is this, to see the difference. Okay, so now let us see what are mixtures. As I said that if the compound is not in fixed proportion, it will become a mixture. Let us see how. Mixture. Okay, mixture. No. Nation of two or more elements here. If we talk about any proportion, means it can, one can be less, other more, or like that. But if coincidentally it becomes same, then that will form a compound. Okay, so this is a minute difference between compound and mixture, and this is only the difference between compound and mixture. Now let us study that how we can represent these elements. So let us study about symbol. You all can take the screenshot or pause and copy. Okay. Symbol. Now, symbol is like the short form, like we have in computer RAM. This is the short form of writing read SS memory. This is a short form of writing this. Similarly, in chemistry also there are short forms for representing any compound or any element. Okay, so you can see is a short form for representing element. Okay. Like for example, BE. It stands for beryllium. So like that. This is the symbol. This is the symbol, and this is its abbreviation. I'm sorry. Then let us see that, okay, we use this symbol for the representation of element, but why is it so important? We can write the names like this, but why is it so important to use symbol, or what is this its importance that we use the symbols? So let us see that. First is that it represents the name of an element, like Be. It represents, yes, that it is beryllium. So instead of writing such long name, such abbreviated name, we can write in short Be. Okay. Then the element will never, the symbol will never represent a molecule. It will only represent an atom. Okay, so it says that there is only one atom. Then it also defines the mass of the element, like in grams. Okay, but to those who are very lazy and not interested or feels learning the symbols of the element is so annoying and irritating, but let me tell you that this is useful only if you know these. So you all can give a try to learn the elements symbol. Now let us see the valency. Valency. Valency is the combining power. Is a combining power of an element. In short, or in simple words, that valency represents those numbers which shows that how easily this can an element can form a compound, or the element's atom can form molecule. So it represents that. Okay. Like if we take the example of HCl. HCl. It represents, this is H, I'm so sorry. Now, especially now for 2027 students who will appear for board examination, your class, please avoid writing this, because now it has been put forward that the symbol of the element who has two letters, it will be broken. Like I wrote B like this, no, but I have to write BE with broken letters. But let me tell you that if in beryllium BE are the starting two letters, but in Cl, chlorine, L is not the starting one, so you cannot continue that. So this is why it is like this. Now this means that there is one atom of hydrogen, one atom of hydrogen plus one atom of chlorine That means the combining capacity is what? 1. So the valency here becomes 1 of this compound, not of H and Cl. But if you'll see that the valency of hydrogen and Cl is also 1. Okay. Now, if we take the example of NH3, here is N, it forms H, it forms bond with H means one atom of nitrogen combines with 3 atoms of hydrogen. Means the combining capacity or the combining power of this one atom of nitrogen is 3. Therefore, the valency of nitrogen becomes 3. Okay, so this is all about valency. Now, let us study about variable valency. Let this be. Variable valency is the elements which have 2 combining power, means which has 2 valency, like copper. It has 2 combining power, 1 and 2. Any bond in which 2, like in copper or cupric oxide, copper. Now let me tell you one thing, then it will be more easier for you to understand. If there is the element which has 2 or more valencies, in this case the elements, the lowest valency of the element, here the lowest valency among these two is 1. So here in copper the suffix OUS is added, so cuprous for this, and here the highest among this is 2. So here in this word copper, suffix IC is added, so cupric. So the example for the second one is cupric oxide, which is CuO. Okay, CuO. Now I'm thinking of the element who is having this copper with valency 1. I'm thinking of it. Second. Okay, copper hydroxide. Yes, cuprous hydroxide. Cuprous hydroxide means oxygen and hydrogen. So here it is CuOH because this also has valency 1 and this also. So but now why this you understood? Now let us move to formula. We had studied symbol. Symbol was the representation of the elements, but but formula is the representation of the molecule. Okay, the formula is the representation of molecule. So this is the difference between formula and symbol. So let us see formula. Representation of molecule is only formula. For example, Cl2. This is made up of Cl. So this way, this is the molecule, and the representation of this molecule is termed as formula. Now let us see the radicals. Radical is nothing. Again, radical is nothing much as we are representing the elements and the molecules using symbols and formula. Radical is also the same thing. Radical is also the same thing. Just what happens is the sign, a sign of negative or positive is added to symbol or formula. Okay, this is only radical. Now, the radical with negative sign is known as acid radical, and the radical with positive is known as basic radical. Okay, so this is the only difference. Now how we'll form the chemical formula? Simple. Chemical formula means formula of compound. Okay. We'll take any compound like MgO. We'll write Mg. We'll write O. We'll write the valency here. It has 2. It's also valency 2. Then cross multiplication, we'll write 2 here. 2. Now as these both are same, it will get cancelled. Like if it is 4 by 4, it will get cancelled to 1. Same. And what will remain if this is cancelled? Then mg remains and o remains without this. So we'll take it together and write mg. This was for making you understand, for explaining purpose. But the normal syntax of writing is this. It implies that side. Similarly, if we take CaCl2 Ca, here generally I am writing the names, no, but here the names are not written, and like the symbols are not written, the names are written. I'm so sorry. Calcium. Now one more thing, that if you are writing a molecule, okay, the second element's name will be in cursive. So we'll write calcium here, chlorine. I'm into habit of this. Okay. Calcium has valency 2. Chlorine has valency 1. Cross 1. Now, bound of calcium is 1. So nothing. Chlorine is 2. So Cl. This will be the way of writing. Now, let us study about chemical equation. Chemical equation is nothing. Let me tell you. This, there are 3 ways of writing a chemical equation, and there are 3 types. Like first is in which element plus element gives compound. For example, H2 plus O gives H2 plus O2 gives H2O. Okay. Now the ones, those are this side, left side of the arrow, are termed as reactants, and those right side of the arrow, these are termed as products. Now there is a law that the number of atoms of each element on reactant side must be equal to the number of atoms of each element on the product side. And this is only termed as balancing any equation. How will balance? I'll tell you a simple trick. Jot down the name, the symbol of the element. Okay, in rough. Here also same. Here it is 2. Here it is 2. Here is 2. Here is means into 2. If you are multiplying this into 2, this as a whole will also get multiplied into 2. It will give you 4. It will give 2. This is for balance. But this is now as it is individual, we can multiply. multiply this side also. 4 equal to 4 to 4. We got it. That means we'll have to multiply this with 2. Here these with 2. Okay. Now the second one is element plus compound. Okay. Element plus compound will give compound. This is, for example, Cl plus NH4. Okay, NH4. Now, please pay attention here. This is element and this is compound. And this will give what? Compound. Okay, so this will be NH4Cl. Let us see whether it is balanced. No, it is not. Here we'll multiply by 2. So 2Cl will be there. But here we'll multiply by 2. This is balanced. So simple. Now, the third type is compound plus compound gives compound. Like, for example, you can see AgNO3. AgNO3 is silver nitrate plus NaCl, sodium chloride, the salt which we consume in our daily life, gives AgCl2 plus NaNO3. Okay, so this is the equation. As this is balanced, nothing to do. Sometimes for confusing the children, the teachers, they give the balanced equation. So please be careful during balancing the equation. Now, as we have come to the end, so if you all have any doubt, you all can comment in the comment section. Thank you.